Yo, what's up? Good morning. We're currently finalizing the rework of Terraforming, and I'm just gonna jump right in. Let's see what we manage to have the time to implement today. So I think we're in the process of fixing this information here, or actually we wanna. The Terraform system previously went directly to the terrain patch. This time around we want to go through terrain base to terrain patch. Terrain base is going to handle, like, there's no reason for the terraforming module to know about terrain patches. It's just one terrain. That's all it needs to know, really. And right now I'm just printing all of this information we might need. So we have a position in world space, global. So somewhere, like if we hit the terrain base, we will always have a position in world space where we hit it, right? And let me put this one, maybe we want to make it a little bit bigger eventually, but this position in world space has a position terrain normalized. What that is just the position in world space normalized to the boundaries of the terrain. And when I say boundaries of the terrain, I mean this white outer box we see here. It's a little bit weird because we have this white line here, but whatever. So it's just position in world space, or position WS transformed to this boundary space. So if we have X, Y, Z, so this point is just 0, 0, 0, 0, 1, 0, 1, 0, 0, and so on. Very nice. And then we have terrain patch index. I think we got this one to work. So that's pretty much just which terrain patch is it, because if we take a look at our environment, we have a few, or actually 4 times 4, 16 terrain patches over here. So it's just which one of these. This one is index 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, and so on and so on. I'm pretty sure we had this one working. And then what we want to calculate is terrain patch UV. Or I wonder if... I think we're gonna call this one position terrain patch normalized. So basically what the UV is a pretty good name. That's true. And that's basically what we're gonna use it as well. So we have terrain patch UV. So for each terrain patch, we have UV coordinates going from 0, 1, and 0, 1. And if I remember correctly, these were not yet a little bit worried about this one. These were not calculated in a good way just yet. So that's what we're going to start with. Let's take a look. Terrain base, what do we do here? Position patch UV, terrain patch UV, and we calculate it here. MathF inverse lerp, terrain patch bounds min x, terrain patch bounds max x, and then we do point x and point z. Yes. I wonder. Yo, what's up, PG King? Happy Friday, happy Friday. I wonder why. Okay, so the reason I see that this one doesn't return or calculates the correct value is probably because the bounds here are wrong. So bounds. There we go. How is the project going? It's going pretty good. I haven't been able to stream as much as I would like the last couple of weeks, and we have ran into some very weird problems. I'm definitely gonna try and make a video about. But we're moving forward, and soon, like I'm looking forward to it. In May, we're gonna implement some old school game logic, and it's gonna be extremely fun, I think. But right now I'm just trying to get my Terraform to work with the old system. So to summarize, in short, how is the project going? It's going all right. Thanks for asking. How about you? What have you been up to these past weeks? Hacked game dev guide, what's up, bro? Are you indie developer? Yeah, I would say. I'm a game developer. I'm independent. Yes. My answer is yes. Okay, let's take a look at these bounds here. New bounds, transform position, mesh filter, shared mesh, bounds, extents. I want to take a look at mesh filter, shared mesh, bounds, extents. This one I worry about. But. Okay, so why isn't this one okay? Let's take a look and do we draw gizmos here? No, we don't. I want to draw this bounds just to see if it's what I assume it to be. On draw gizmos. Yeah, let's keep it like this one. Draw wire cube. Bounds.center. Bounds.size. It's not extents right, so let's try this one. Scene. Yo, what's up, Little Miss Murder? Long time no see. Good morning, good morning. What? Did I screw up the on draw gizmos? Yes, I did. There we go. Little Miss Murder, I see lots of progress has been made. Yes, some progress has been made. I can summarize what we have been doing the past month or two, I think. It's summarizing stuff. Sometimes I hate summarizing stuff because it makes me think that we're moving in at a slow pace, but whatever. I'm enjoying it. So we were working with displacing a mesh, which we always are, but this time we did it with the snow. And when we were displacing it, we got some really awful artifacts on the displacement. So then we dove into tessellation and fixing up the geometry. So we did that for quite a while, but we finally arrived at a pretty good tessellation solution, which is modular, so we can use it for multiple different stuff. So then we went through all of the shaders and game logic that uses displacement in some way, and it turned out to be most of it, because we have the terrain, we have water, we have snow, multiple different stuff. So we went through that, added our new tessellation solution to it, and it pretty much reworked some of the different parts. And so that's what we're currently doing. We're going through everything and making sure that everything we had working is working with the new system. And right now it's terraforming. I think we have improved a lot of stuff, so I'm happy about it. That's pretty much where we're at. And then I have promised some game logic implementation soon. So as soon as we have everything back to where we were, but with a better system behind the scenes, then we're going to do some game logic finally. Hacked Game Dev, I hope that summary worked for you as well. So we currently, we have this nice terrain, and now we want to terraform it again, but in a nicer, better way. Let me see if I can bring this one up. One problem I had with, I can't really show it in action right now because the full pipeline isn't in place. But if we take a look at the problem I had with the mesh is that the tessellation. So when we have underlying height data, right? I wonder if I still haven't, maybe I haven't chosen the correct way, but anyway, I had a problem with the topology like this. If you had a height change that were orthogonal to the triangle split you do, you get some really bad artifacts. But now what you can do is you can do quad flips, but we opted for this solution instead. So I think our terrain should be yeah, we have this topology instead, which I like a little bit better, but I don't know. We'll see. And all of the terrain and stuff like that is now fully, like, the GPU handles a lot more this time around. So previously we actually went, when we did terrain terraforming, we actually did it on the CPU. But now we do most of the stuff on the GPU, so that's what we're gonna try and get in place today. But I hope all of this makes somewhat sense. Hopefully it will become clearer as we go. Like previously we calculated normals on the CPU, but this time around we have packaged the data in such a way that we have all the data we need on the GPU, so we can calculate the normals on the GPU. It's a little bit quicker. But okay, so we can see here that the bounds are wrong. Did I screw up? Bounds Oh, yeah. Bounds. When we create bounds here, we do it by size, not extents. So we just need to multiply this one with 2. And we should be good to go. And now I wonder if my terrain patch UV information we have here, it might actually be correct this time around. Okay, so now our bounds are good. We can see here that the height doesn't really work, but I don't think we care about the height for these. Or of course we would like those bounds to be correct as well. So I wonder, terrain base, we're gonna have to do a little bit more. Are you only applying tessellation inside the bounds that have terraforming applied? Now we're applying it only based on view distance currently. Terrain bounds, yeah, we do this stuff. We want to do this here as well, I think. That implies you will have terrain popping. Terrain popping. So you mean when we move closer, we tessellate it once more, and you get this popping. Yeah, that is one problem we unfortunately have on hold, which I'm not that happy about. The damn terrain popping. Yeah, we tried to figure it out. I think we were extremely close. Like extremely close. But then I felt I spent too much time on this. We can wait with this issue. So that is something that will eventually go in our modular, what is it, tessellation pass. Yeah. Someday when I feel extremely bold, we're gonna give it another shot. You will figure it out, you always do. Thank you, I appreciate it. Sometimes it feels like I bang my head against an issue and don't solve it, but so this, I appreciate it. And most of the time we actually do solve the issues we face. Yes, but okay. Mesh filter bounds here. We have a little bit of we have some experimental stuff in this new system, which I'm still not 100% sure works that good. But one thing that we do in this new system, which I like, is that we only create one mesh. Little Miss Murder, thank you, appreciate the lurk. But one thing I like with this new system is I have newborn kittens to feed. Oh, nice. Nice. Pet them from me. Meshbuilder.create, we only create one mesh here, which we reuse over and over and over. So the terrain system we see is just one mesh rendered at different positions. The water we're gonna have is just the same mesh rendered at different positions. The snow we will have is just the same mesh rendered at different positions. And this I absolutely love. If we want to go crazy later on, we can probably do some sick optimizations here, even more so. But okay, I want to get the correct bounds for my terrain patches when it comes to the height as well. So I wonder. The terrain patch knows nothing about terrain base. So when we call bounds here, we're gonna double check. When we create this mesh here, we send in this base mesh resolution and quads, and then we actually fix the bounds here. Patch dimension. Okay, beautiful. So I think we can just do bounds position size. I want to offset this position with .y. Times something like that. The height of these terrain patches, we don't really care about those for what we're trying to do now. But I mean, we will probably need them eventually. Okay, so this time around, fuck, did I offset them in the wrong direction? How the hell did I manage to do that? Oh yeah. We want to do plus here. The only thing we really care about here is the terrain patch bounds in X and Z, because if we have those, then we can normalize our world position to be normalized to those bounds. Okay, this looks much better. So what I want to do now is, so now we can assume that these bounds are being correctly calculated. I don't care about drawing this cube every time. So now we're gonna see if so when we do terrain base and we do get information here, we calculate terrain patch UVs, we do inverse lerp on X and Z. Now we can assume that these bounds are being calculated correctly, so hopefully our UV coordinates are as well. Do I have a lot of errors here? Hopefully not. We just clear them and hopefully they don't appear anymore. 0.65, let's run a little bit and see here. So we can see terrain patch UVs growing up to here. Yes, and here they flip. So terrain patch index 1, 2, terrain patch UV 0.51, 0.99, 1, 0. So when we flip terrain patch index, we flip the UV. That's fucking beautiful. It should work in this direction as well. And it does. That's great. Hackdev game dev guide, your portfolio. Oh, we're talking about my YouTube channel. Okay, this is good. So now when we have the UV, now we can start printing a lot of stuff here, and we're gonna do it in such a nice way. So hacked game dev guide. I don't have a dedicated portfolio. I wouldn't say. Maybe I should get. I don't really see the need for it currently. But like I think my YouTube channel speaks for itself. I have some pretty good devlog videos, which works as tutorials sometimes. I have some short videos. I have all my live stream VODs on my YouTube. I think that speaks for itself. Although I don't know if it's good or bad, but my devlog video is probably good. So what I want to print here now is I want to print all of the different terrain data we have. Currently, we define here what data our terrain stores. We have height, foliage, water previous, water temporary, activity height min, activity height max, activity direction strength. So I want to be able to highlight a specific point on the terrain and show what data we currently have there. We do have, in fact, do I have these? One thing I'm not entirely fond of currently is that with this, when we rely only on the GPU, when we do when we recompile shaders, the data we have sent down to the GPU is resetted as well, which sucks. But so currently we have a debug system, let's see here, where we can actually show the different data for our terrain. But I want to be able to see, so for this point right here, what exact data is stored in this point. And actually, we're going to add a few different stuff here. I want to add position world space, position terrain, normalized terrain patch, index terrain patch, UV. I want to add, I think I want to add global index as well, and I want to add terrain patch index as well. So if we highlight this one right here, I want it to show the index of this terrain point with ints. So I don't know what this would be, 243, 125. Hat Game Dev the Guide, by the way, I watched those, are good. Thank you, appreciate it. I'm very proud of them. And then I want to show the index for the terrain patch as well. Okay, so let's do those before we play again. So basically we want to add global 2D index, add terrain patch 2D index, add terrain data information. Terrain data information, I think, is the simplest one. We're just going to do this, and Yeah, I don't want to have any methods. Hack Game Dev Guide, sorry, but I have to go. No problem at all. Thank you for dropping by. Appreciate it. And have a great rest of the day and a great weekend as well. So when it comes to terrain patch, I want to keep terrain patch very thin. So we should probably put most of the logic in terrain base. We're going to put it in here currently, but eventually, so this one is going to be its own method. This one is going to be its own method. This one as well. Just a few different methods for getting information and stuff like that. So what I want to do here is we want to do string terrain data information is equal to, we just create it as empty, and then we do for each. In fact, didn't I have it here? Here we go, terrain data types. So terrain data types. This one defines all the terrain data types we use in the system currently. So we do for each terrain data type in terrain data types. And then we do we're gonna print two values per data type, I think. We're gonna print float value and real value. This one is already fixed, so we can remove that. We're gonna do it like this. Let's see here. But here we actually take a 2D index, int x and y. The thing is that the terrain data container has get value by UV, where we calculate the index like this. I wonder. Yeah, I think we're gonna do this. Get value by UV. Instead, we're gonna have public vector2 int get UV as get the index from UV. Oh, we don't use float2 here. And then we take these calculations right here. and return I wonder where we use this one actually. Height collider, yeah, we're gonna fix this one. So we're gonna do like this, get index from UV. And then I would like a version of all of these, but where we use UV here instead. And yes, and this one. We do index here. Can we do public float value? Should be able to do it like this, right? Or I never remember the syntax for this. Is it something like this? Or do we want to do... Ah, fuck it, let's do some Googling. Lambda. Yes. But then I don't know if we can use this. Let's just do it like this instead. That would be so nice. Or actually, yeah, fuck it, let's do it like this. Index, we do it like this, and here we do value index, and get index from UV. Why not? Feels like something that could be needed. Being able to fetch data values by different types of indice types, maybe. Value byte. This one I'm still a little bit wary about, because so previously all data was stored as byte values. That's no longer the case, actually. Why? So I'm not entirely sure how we're gonna do here. Maybe we will fix this as a T, maybe. So we can get value normalized. So we can get value as float, normalized, and then we can also get it as it's stored. Some textures will have it as bytes, some will have it as floats, I reckon. Also trying to get to learn this new keyboard of mine, which is, it's a little bit hard. Yeah, we don't want to do value, we do value byte. Oh no! Once... Do we actually do index here? We might as well... Is that... Let's do it like this. Okay, like this. And then we have our height collider, which is not a height collider just yet. Get value by UV. Here we just do value. Okay, beautiful. What I care about now in our, when we want to print this information, is value and value normalized, I think. So I want the real value, so the world space value, and the normalized value, so the value between 0 and 1. So terrain base, here we're gonna do type dot as string plus in fact, do we have unit here on type as well? No, we don't. Not yet, anyway. I'm just thinking about which value I want to have within parentheses. So I think we're gonna go rain patch dot get data real value float value. Yeah, fuck it, here we have them as int as well. Real value. It's just value, I think, yeah. Mm-hmm. We're actually going to start with one of these as well. That should be this one. We're going to double check it before we remove this one. Add global to the index, add terrain patch to the index. Oh, actually. This is not entirely true anymore. So previously we developed this system under the assumption that every type of data we want to store about the terrain would be stored in containers of the same size. With this new system we have varying size of them. So maybe normalized UV is all we need. Actually, oops, but one could also think that when we print this information, we might want to have the indices of them. I don't know. I will see. Let's see if this information is correct. Ooh. That's not good. Hmm. Why do we get this one? $72.90 as well. Or $42.90, I mean. Hmm. If we do send in a value between 0 and 1, but I'm still wondering. Get pixel data float. For what value is this? Or for what type? Uh, 4291 is out of range. Okay, so we're just going one too much. But 4290, I'm questioning this. Where do we get 4290 from? Resolution 131 times 131. Where do we have a length of 4290? 64 times 64. Ooh, could be 67 times 67. Hmm. Prototype UV scale, UV offset, UV step. Default is always this one. Welcome back, Little Miss Murder. Bambinitos are fed. I got my first purr out of one of them too. Oh. Yeah, that's a win. That's a win. Oh, did I fuck up? No. No. Fuck. Why? Floor to int. Okay, maybe. Yes. Okay, so when we get 1 here. I still don't get this 4290. How do we get this one? Yeah. Nah. We have a width of 131, we have a height of 131, so we have 17,000 elements. Uh, when do we get this one? I would guess we're probably gonna get it when our UV becomes 1, I think. Oh, okay. Look at this. Here we have the seam as well. So we can see this is the same spot. One side of it is... Oh. One side of it is terrain patch 1, 2. And the other side is terrain patch 2, 2. That's beautiful. But why... Mm. Was this in from... Ah, here we got it again. Why? It makes no sense to me. Hmm. Is one of these... Oh, whoa, 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 whoa. Terrain data type. Now we get type resolution here. And that's what we created with. Height, foliage, resolution, resolution. Resolution, resolution. So all of these containers, data buffer here though. All of these containers are being created with type resolution. Currently, type resolution returns the same for all of them, which is 131. 131. So all of them should have this size. Right, we create it here. But, when we then do this one, pixel data, get pixel data byte, get pixel data float. Oh, have I screwed up here? So we have 17,161. Let's say that we create it as bytes. So we do times 8 divided by 32. And there we have it. That's the problem we have. Okay. We assume that all data is stored in this texture is stored as floats, but that is not the case. Terrain data type, texture format are float. That's 32. But here, texture format are 8. That's just 8 bits. ARGB 32. And that's 32. Yo, what's up, Bush? Terraform is still going strong. Hell yeah, man. Hell yeah. Refining. Okay, so my bad. We need to handle get pixel data type byte. We can't do it like this. Value normalized. Set value is also crazy. Every get pixel data, we need to get pixel data as the actual format we have. I'll double check one thing here. Let's go texture 2D. Get pixel data. Color 32. Can we do get pixel data texture dot no, we can't. Fuck, we need to know this at runtime. Let me do this, but I guess we could do. We want to get pixel data, get pixels, but this is as color structs. As color 32 structs. Gets the raw data from a texture. Yeah, we're gonna do this, I think. But I mean, we could probably create a buffer up here, the correct one based on format. But is this where we're gonna have to add some generic shit here? Use t parameter ourselves as well. Bush, do you intend on writing a fur shader? I would be very interested to see how that's done. Actually, I do. Um, um, but I can't tell you when. I've been intending to write a fur shader. We're gonna use it for fur, definitely. But I also want to try. I want to see what kind of result you can get if you mix, because the usual way you do fur, I don't remember what it's called exactly, the approach, but the approach I have in mind, I want to see you can also use that approach for like grass and foliage and stuff like that. And I want to see what kind of result you get if you mix uh, the fur approach for grass and the geometry approach for grass in one shader. So if it's very small grass or low grass, short grass, I mean, then you mostly render it with the fur approach. If it's tall grass, you render it with the geometry approach. But yeah, we're definitely gonna make a fur shader, but it will probably be after the summer, I reckon. Okay, what I hate here, like we shouldn't need to obscure this or generalize this, because texture 2D should do that for us, but we do want to get specific values. So basically what I'm getting at is this one right here and this one right here. We want to merge those, and we want to base this one. This one should be T like this. So we want to do terrain data container. We want to do something similar to this one. Terrain data buffer container T. Terrain data buffer container. Timestamp. What the hell? Can we just do... Let's experiment a bit. Terrain data texture container B. Texture 2D. We want to base this one on this one. Format. I wonder. Texture.format dot to compare to what the, get type probably only returns. What the fuck? What am I thinking about? Let's do it like this. We can keep it like this for now, I think. We just need to do... Shouldn't we be able to format... can't we have like data size or something like this here? Fuck, it's that weird, by the way. Byte. E... Thinking, what is the best way to get this? We need to know it. Like, do we want to solve this at runtime or compile time? Probably compile time, right? But can we do, if we do T here, could we do T? It must be non-nullable value type in order to use it as a parameter. Do we need to define where T not null? That's a lot of stuff. Texture 2D should be able to handle this. We could do get pixel. Like, what we do have here is a lot of methods that just converts whatever underlying data structure we have to color. And I mean, that's nice. But that's not what I want to work with right now. Me do where T struct. Okay, beautiful. Great. Okay. And then I wonder if although I wonder what would happen if index bytes per index value index. Like, do I just want to skip sending this one in and instead we create it with this one? I don't know if that is possible. Texture format R float. So I could guess like here we want to do. Can we do float when this one is struct? So many questions. And this one is byte then. How the fuck did this work? It should work. Float. Yeah, we could, for now we could do it like this. And then terrain data, render texture container, ARGB32, each of them is byte. Actually, this one is a render texture. We haven't fixed that yet. Fuck, will this work? Feels weird. Let's try it. So when we do value, or when we do value byte, let's see here, get pixel data. Var feels weird. T, 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 T. What can we do? Oh yeah, okay, of course. I wonder if we can do generate values, pixel data I. Generate value. Oh, what a mess this becomes. Yeah, we probably want to add some constraints for ourselves here. Convertible, I don't know. This would be pretty easy. T. Okay, but if we change that one, then we need to go to terrain data container, make this generic as well. What can we do? Okay. If that's the case, we're gonna have to add something else here as well. And here we generate values. Mm-hmm. It's these. We should probably Oh, I think we can develop a very nice system here. But I don't know if I want to do it now. Create data buffer content. We would create a custom struct, a few different structs that, yeah, probably are ruled by some interfaces like this. And then we use the same, yeah, and then we use it here. T, where I think that's nice, but I don't want to do that today. I need to properly research and structure it. So let's do a quick fix here today. We should be able to just make it work. Okay, so the problem we have is that we try to get a float value when we actually have bytes behind the scenes. And it is... It's this one that is the culprit, I think. So we don't care about byte values now. But then we have this one as well. That's true. ARGB. If we try to get these values here, we'll be fucked as well. Actually, what we can do, instead of doing pixel data, like this. We could instead rely on get pixel, I think. Which we package it to color struct. Or actually, if we just want to... can we do it like this? If we just want to solve this real quick, we can probably just do... we check it at runtime. So we have get pixel data. Depending on format, we either do get pixel data byte or get pixel data float. value index. Or could we just do for now? Yeah, we're probably gonna add an issue for this. I'm a little bit worried what will happen when we get to UV1. That actually works. Okay, that's beautiful. So right now height. So right now we represent every data we put into textures. We represent with float values. That's overkill. I'm gonna have to make an issue that fixes that. That's like the fourth issue regarding the underlying data structures. But in small iterations, it gets better and better and better and better. But height we need at least 16-bit precision, I think. Foliage we can definitely do with just 8 bits. Water as well, probably. So yeah, eventually I need to take care of that. Okay, but I like this. This will work for now. height, foliage, activity height, min, max. Min doesn't work, but max does. It's a little, the offset is fucked, but this one. But we don't get the data here for some reason. Hmm. Yeah, want to take a look at that soon. Right, direction strength. Water, no water. Okay, so I want to create this issue because I want to remember this. I think we can make it so nice. So nice. Okay, for now we just force float on everything. Except for this one, then we do. Yeah, it's a little bit different for water, but for this one we do. And let's see, terrain data type. Oh, we are gonna fix this. I've been meaning to redo this one as well. Let's check. Terrain data type. Explore better terrain data type definitions and possible rework. Beautiful. Rework terrain data and underlying systems. We still have these as... I want to double check both of these. Mm-hmm. I don't know when I want to do these two, but if we can get this one in place and then we fix this one, then I'm pretty sure that this part of the backend is done. Like if we take a look at the terrain data type currently, we do this enum approach with static methods, and like these belong together, these belong together. It's weird and messy. But if we could do something like this one, I've talked about this previously, I'm very fond of this. Like enum animal, dog, cat, enum dog, bulldog, so you have nested shit. This is beautiful. So I want to try something like this. And if we do it like this, we also get, like each type can have its own methods and values on stuff like this. Yeah, I just think it's cleaner all around. Maybe I will take a stream. We will probably have a stream in the future where we explore it. Just see how it looks, how it works. But okay. Terraforming. Okay, so now we have this in place. And it works, I think. Yo. Aim. What tree are we talking about? What are you making? I'm making a creature collecting game. Think Chow Garden. Sonic Chow Garden. And not so much Pokemon, but I mean, everything involving creatures is always going to be compared to Pokemon, but more Chow Garden, Viva Pinata kind of shit. And we're doing we're refining some of our systems, more specifically the Terraform system. One sec. I just need to check if it looks like it's going to start raining here outside, and I need to bring some things in if that's the case. Let me just check. Oh fuck, 40% risk of rain. I'll see. C sharp, yes, C sharp. We're developing this in with the Unity game engine. So we use C sharp, but we also write a hell of a lot of HLSL over on this stream. I've done a lot of shader stuff. You know what? I'm gonna bet that it's not going to rain today. Yeah. Or, yeah. HLSL, or what is it? High level shader language, I think it stands for. Okay, so now when we have this in place, I probably want to put these into their separate functions, because the pipeline is something like this. We have action, interaction, terraform. It it's dependent on action, interaction, focus. So when we focus something, we can terraform. We get to ready here, and then the player can trigger terraform. And we call terrain-based terraform brush. Instead of doing all of this, we just do this. I think that's beautiful. Yo, I got an app idea. Shoot. Let me hear all about it. Terraform. Yes. We send in a brush. Fuck, we had this in place previously. Let's see here. Terraform data, Terraform data row, terrain patch terraformer. I don't think we need any of these anymore. We just need Terraform brush visualizer. Although we'll see, we might want something. I don't think so. We don't use this, we don't use this. I don't want to use this. Terrain subset, this one. Do we use this one now? Okay, I love this. I think we can make this extremely nice eventually. AEM, let's see. Scan the back of food items with their phones to let them know it's healthy to eat or if there are any probabilities of poisons like pesticides or hydrocarbon-based additives in the food you're thinking about buying. Yeah, I love that stuff. I mean, it's a great idea. But does it exist already? No one has done it yet. Yeah, maybe not. But I know that, like, there exists a lot of exercise apps where you can scan food items and get a rundown of what it contains and stuff like that. Yeah, maybe. But the focus here is maybe more the pesticides and stuff like that. What would one have to do? Does it exist some easily accessible public database on that kind of stuff? Or are you gonna have to crawl the manufacturer's websites? Yeah, exactly. Oh, that's good. That's good. So I mean, Companies probably, I guess they have to, in most countries, or in some countries, they have to state these kind of things, but they usually hide it behind a lot of links and navigation. So yeah, crawling for that information is going to be the biggest problem, I think. But once that's done, then you got it. In fact, makes me think, I live in Sweden, so part of EU, and I fucking love it, but EU is very... They have a lot of constraints on food and what... like how healthy they need to be and stuff like that. I wonder if, I think EU might even have some sort of labels, or if one want to sell food in EU, you need to label it related to pesticides and stuff like that, I think. Let's see here if I can make a quick Google here. I wonder how true this is. Like, ideally, we should be able to scan a code. I 100% agree. Yeah, I don't know. Scan a QR code and follow the systematic growth of each product. That fucking rocks, man. I can imagine that companies that really want to be green and really show that their products are grown in good conditions and such, they will freely give up this information. But finding this information for products from companies that are not so nice, they're probably going to hide it behind some weird link trees and stuff like that on their website. I guess they have to disclose it, but they're going to make it a little bit harder to find the information, if you know what I mean. But I think it's a good idea. I think it's a good idea. Yeah, some companies are shit. Most companies are shit. Okay, so during this project, I've had a lot. So Terraform Data Row, they are all CPU based. Terrain Patch Terraformers, CPU based. We have Terrain Subset, CPU based. The hardest part is going to be... So when we call terrain base and we call terraform here, we send in a brush with a size. And we need to convert... so this one right here, terrain patch UV and terrain patch, we can actually, so one point we focus on might actually be to so one point might actually belong to 2 terrain patches. So if they use tech and engineers that incorporate the system to be open information, this can be doable. Yes. Yeah, I think the biggest problem, or the hardest part about that app is going to be to fetch all of this information. But like, depending on the regulations for the country in question, it might be an easy task or it might be a very tedious task. You know what? I'm gonna run AFK real quick. I'm just gonna bring some stuff in because it definitely looks like it's gonna rain. So be right back a couple of minutes, then we will continue this. Okay, so back. Sorry about that. Let's see. This right here is a little bit. It's quite a complicated stack we have. But let's see here. So we have a UV in normalized space between 0 and 1 for the full terrain base. Now, so when I say stack here, I mean from the user input to the terrain being terraformed. It's quite a lot of layers we go through. So 2 terrain patches can, or 1 terrain point can be is represented and can be represented by 2 terrain patches. It's the overlap problem we have. I think that's going to be the biggest culprit. So when we terraform sometimes, let's take a look at this. When we terraform, so this one right here, is your work open source on GitHub? No. I have some smaller parts that are. But like if we mark this position, this area that is highlighted here stems to terrain patches. So we have terrain patch 1, 2 and terrain patch 1, 3. And so that means like our terraform is basically going to be a blit action. We're gonna blit our terrain brush into our terrain texture. So we just need to calculate some UVs, pretty much. I think we have done this before, but now we have a new system in place behind the scenes. So it's going to be a little bit different. We just need to make sure that we mark the correct amount of terrain patches. How do I want to do this? AEM, so you're taking the graphics engine and condensing it? No. Okay, the problem we're trying to solve. We have solved it previously, as I said, but now we want to do it a little bit differently, a little bit nicer, I reckon. Or that's always the goal. So we have let's say that we have our terrain like this, consists of 4 patches, and then we have a marker here. Our marker is always a center point, a width, and a height. We want to get all terrain patches within this one, and then we want to create this as parameters down to a shader that does a regular blit. I would love to be able to do blit. Let's see here, command buffer Unity. AM, is this only playable on computer? Yeah, that's gonna be, that's the initial plan. Then we'll see where it takes us. Shoot, I love ideas. Don't have the time to build anything else currently though. Source destination. Our source is always going to be small. I would love to be able the scale to blind offset to apply. We can probably make some nice things with this. Full screen surface. Yeah. I'm interested in these two. Don't we have some more information? Because when we blit a small texture onto a big texture, we're probably gonna execute the shader for every frame in the bigger texture. Would love to avoid that, if possible. I know that we have Terraform shader. Yeah, so we're probably gonna use this one. But we're gonna make it use the blit library. This I hate, so we're probably gonna have to do something similar to this. We will take the floating point errors into account. So eventually what we want to do is Uh, 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 uh. I wonder if we want to pass this on to terrain data container. Should do the final stuff, I think. So terrain brush is going to set up its material, and then we'll use a blit here. So I would say terrain base. Hate this. I'm pretty sure I want to do this. If we could do this as a render feature, it would be amazing as well. But let's see. Does that file have no pointers? I don't know what you mean. C# uses points to reference other files. All of this is already handled behind the scenes. Nothing we need to care about. A lot is probably done by Unity, I would bet. Okay, the problem I want to solve here, the problem we need to solve first of all, and I think it's, if we solve that one, it's probably going to be pretty easy, the rest of the stuff. I want to fetch all of the terrain patches we are currently hovering above. Previously we did this with a physics overlap box, which is it's a bad solution for what we want to do. So we should be able to do this. This one, or these lines, they pretty much always make sure that we only focus one terrain patch. I want to make this one work with multiple terrain patches. So we might have a UV that is... Let me show what I'm talking about. Have we yeah, this one, for instance. So right about this point right here belongs to terrain patch 1, 2. Come on. This point right here belongs to terrain patch index 1, 2 and terrain patch 1, 3. Currently, which one we're focusing depends on what side of the center of the pixel we're located at. We want to make sure that both of these are included for this one. We round down and we round up. AAM, so that should be its own file where your other lines can reference to. No. I have no idea what you mean. Are you allocating any of the data to specific memory spaces? Depends on how specific you mean. Okay, I think we're gonna do... Yeah, we're gonna calculate a minimum XZ and a maximum XZ. So we're gonna do one that does floor to int by this, and one that does ceil to int. And then we will hopefully get the terrain patches within. So Terraform brush, we're gonna have to do this one. So let's see, position terrain normalized. Let's add a method for this. Wake. What is the syntax for transform direction, transform point, local space to world space? Transform point. Actually, so yeah, I just want to take this one. AM appreciate it, but yeah, I think I have a pretty good understanding of it. And like the problem we're solving right now, or the functionality we're implementing now, we don't really need to care that much about those specific things. Okay, so then we have this, and we're gonna do this for a few different points in Terraform. So we have a brush here. We have radius. The thing is, I wonder. I wonder how careful we need to be. rush radius here. Trying to think if we want to truncate the positions before or after, if it makes any difference at all. Probably not. Oops. Yeah, we can probably not use this one. Fuck, can we? We have to keep in mind that the underlying data textures, they are overlapping. Quite a lot, actually. Or 1.5 pixel in each dimension. So we can probably get, like, this is the UV non-scaled. Non-offsetted. Yeah, we need to be real careful here with the transformation between spaces. It's extremely annoying because what we actually have my buddy's writing a game from scratch with an old computer. It's all memory allocation when it comes to spaces, and there's no blending. That sounds tedious, to say the least. So if we take a look at our terrain patches behind the scenes, we actually have something like this. We have a nice, or I don't know if I want to call it nice. We have an overlap like this, and it's very important that we keep track of this when we do our terraforming. So this point, for instance, if we have our marker here, it's actually 4 terrain patches. And what's up, Hunter YouTuber? We need to calculate the UVs. What I'm afraid of is that we get some, we can calculate some overlap here, but to YouTuber, I just watched the devlogs about cell shading and character creation. My mind is blown. Thank you, appreciate it. I will try to recreate the cell shading effect for my game using your video. If you're using a older version of Unity, I have the cell shading, the cell shader related code is available on my GitHub. It's a little bit outdated these days, however. Yeah, unfortunately, it's a little bit outdated for Unity 6, but the logic should still be there. I've been meaning to update the repository for Unity 6 because I'm sitting in Unity 6 right now. I just haven't gotten around to it. I don't have the time, unfortunately. Okay, the problem we're trying to solve here right now, it's all of the different offsets and scaling and stuff like that we are working with throughout the system. It's all of them at the same time here. We need to take into account the offset and scaling. How can we do that? Because this UV we get here, okay, we're just gonna have to, yeah, we're just gonna have to inverse offset and scale it, I think. Maybe. On YouTube, I'll still try and see what I can do. Good luck, good luck. Hopefully you get the result you want. Okay, you know what? Unfortunately, I need to run in about 4 minutes. AM, you want to see my cool 3D wave function? Link it and I might take a look. But I just need to summarize this stream. Because I need to run now. But when I get back next week, we're gonna get this in place. Hopefully I will have the time this weekend to actually structure the problem and make it make sense. Because what we're looking at here is the fundamentals of the problem is quite simple. We just want to blit one texture into another texture. But where we do it, like the scaling and offsetting, is going to need a lot of calculations. But hopefully I have a nice plan how to proceed on Monday. Yeah. AEM, you don't have a like Imgur or YouTube link instead? But okay, yeah, I'm gonna stream next week as well. Hopefully we can get to the bottom of this. I just need to I need to take a break and go through this slowly to proceed. But thank you so much for watching, everybody, and have a great weekend. Peace.